So in chapter 8, optical property of you should master the absorption, reflection, refraction, and the transmission of the material, luminescence and fluorescence, and application of the optical property, which can be found in optical fibers and lasers. So what is the absorption of the material? It's described by this profile, which is the light intensity across the material, which is absorptive, is exponentially decay with the depth. And to measure the ability of the absorption, we use the term absorption coefficient, which is given by alpha. And there will be a cutoff frequency as well as wavelength due to the band-to-band absorption. Two ways of absorption, two main ways of absorption. One is from phonon, which is due to the lattice absorption. Okay, so when the light is incident to a ionic bonded solid, such as salt, due to the vibration of the lattice, this wave is transferred, is traveling inside the solid, and the heat is generated. Then the absorption takes place. Another type of absorption is band-to-band absorption. Is when you light in the phonon energy is higher than the band, so that the electron can absorb the phonon so excited from the valence band to conduction band. This is called the band-to-band transition. There is a cutoff frequency as well as the wavelength is given by the band. Refraction and the reflection. So due to the Snell's law, which is the reflective angle is a function of the two refractive index of the two materials. Therefore, there exists a critical angle which is CTC to achieve the fully total internal reflection. So the second CTC is given by N2 over N1. That is the critical angle. Under the critical angle, the light is fully reflected, internal. There is no light transmitted out. So this is significant because the application of optical fiber is based on the total internal reflection. So absorption and reflection of metal is unique because it explains why metal is so absorptive, is so reflective, and as well as is opaque. Why metal is opaque? That's because of the large number of the electrons. So the electron absorption is different from lattice absorption because electron can be easily excited to the higher level, above Fermi level. When the electron is absorbed, a photon, it is excited to a high level, then suddenly return back, emitting a same wavelength for photon. That's called the reflectivity of a metal. That's why metal is used in mirror as a reflective medium. So what about the nonmetals? In nonmetals, lattice absorption is a key form, and therefore the role of the phonon. So sorry, the role of the phonon, not the photon. The role of the phonon is enlarged, and that is partially due to the change of refractive index due to the polarization. Luminescence and fluorescence. There are three ways of luminescence. Can be photoluminescence, which is excited by photon, by light. Can be cathode luminescence, which is excited by apply the high energy beam to the metal. And the electron luminescence, which is excited by the electron field, electrical field. The difference between phosphorescence and fluorescence is time. The process, the transition time. For phosphorescence is slow process. For the fluorescence is fast process. Due to the transition of direct transition like fluorescence and indirect transition like phosphorescence. So the time is different. So for phosphorescence is slow process. Fluorescence is fast. Applications, as I mentioned before, the application of optical fiber is due to the confinement of photons inside a fiber. how to achieve that is you engineer the refractive index of two materials so that total internal reflection is over 10. That's the principle. Laser, what is the principle? Is the band-to-band transition. You have the different two levels, first excite electron from the lower level to higher level, then let them to relax and emitting the light. And sometimes you control this transition in a way that it happens intensively. That's the laser. And sometimes you need to engineer the band gap so that the incident excited light, the wavelength is shorter than the emitting wavelength. That's because the band gap difference.